Yes. So if you take an NPN transistor and we say that I want to make this NPN transistor behave as an amplifier. Okay. So what we will do, we will have to properly first bias it in active region. We had seen it in last class. We will bias it in active region. Now we have seen when we take lab classes, we have seen many students doing this mistake, that when we say that now apply an AC signal to it, what happens is that they will remove the biasings and then they apply the AC signal. That is not going to work. Okay, you will have to first bias the transistor with proper DC bias. Suppose there is a resistor, there is this DC voltage with respect to ground. Okay, and then you have an RC. According to whatever your requirements are, you have designed this circuit. Okay, this is your circuit. This will be your VCC here. This is RC, and you will be taking the output from here. Okay, so first let's say that this is the biasing, and we have made sure that this is in active region. Now what will happen when I say that, okay, now you tell me that how you amplify a signal. So what you do is you connect an AC source here now along with the DC. The DC has to be there. Okay, and therefore what we need to do is we have to use a coupling capacitor here. Okay, so that the signal gets coupled. When we are doing the AC analysis, the signal can get coupled to the base. That is the reason why we use this cap. And again at the output we use another coupling cap, and from there we observe the output across whatever. You can use an oscilloscope or you can use a resistor also, and then you can observe the output across it. Okay, so the DC biasing is needed to keep the BJT in the amplification region, and then you, on top of it you apply a small signal. Okay, so now this small signal analysis is what we are going to do. So let's say that there is a small signal change in the input voltage. Okay, so as there is a small signal change in the base, so there will be a small signal change in VBE, and therefore we know that IC is equals to IS e to the power VBE by eta Vt, that we saw again in last class, right? And now since there is a change in delta VBE present, therefore correspondingly there will be a change in the collector current, and once there is a change in the collector current, there will be a change in the base current also, there will be a change in the emitter current also. Okay, so and therefore there will be a change in the output from wherever you take the output. So now we are taking the output from collector, so that will also change. Okay, so now let us do an analysis of this. So we have seen that IC was equals to what? So GM was equals to IC upon VT, right? So this was when there is no change in the input, right? So we had seen that GM equals to IC upon Vt. This was for DC conditions, right? So now when there is a small change, delta VBE, we will see that now the transconductance will make this change appear at the output in this way. Okay, so this is the change in current that we talk about. So that is what the transistorized reaction is, that when you change the voltage, the current at the output change. You change the input voltage, the output current changes. Okay, and that is the transistorized action. That is what the transistor is supposed to do. So now on the basis of this, let us draw the small signal model. Okay. Okay, so now since we have seen GM equals to one thing we have got, this we have got, okay, and this is also written that IC is equals to GM times delta VB, not as delta IC, that can also be written. So now there is another term we define, that is R pi, and R pi is beta upon GM. It is 1 by GM amplified. Okay, and with this let us draw the small signal model for a normal NPN transistor with active region biasing. Okay, so what I mean to say is this one. So let us say that this is the transistor I am having. Okay, so this is B, this is E, this is C. Okay, these are the terminals. So what we do is we have this transistor's resistor will come here, R pi. Okay, so this is R pi. This is R pi. Okay, between base and emitter. And here this is the source, which was Gm times VBE, and this is the VBE. I am writing as this like this, so small VBE. So VBE plus minus. This is a change in the voltage. Okay, and this is the current that results due to the change that we just saw, Gm times delta VBE, right? And that is why that is the current IC here, or small IC. Usually in books it is represented in this way. This is IB, this is VCE, plus minus VCE, right? So this is E, so VBE, VCE. Let me make everything small to show these are small signal models. Okay, that will be better. It will be less confusing. VBE and VB. Okay, I hope this is clear. Okay, so now in normal circuit, if you say that, okay, for the transistor, this terminal was grounded, and this is where I had applied the change, and this is from where I am directly taking the output. Let us say I am saying something like this. Therefore, what will happen? The emitter will simply be grounded like this. Okay, and now from here you can have the equations, which is VBE is equals to IB times R pi, right? And you can see IC is nothing but Gm times VBE, right? And you can then see IC is nothing but Gm into IB into R pi, and therefore you can see that the current gain IC upon IB is nothing but Gm times R pi, which is nothing but beta, right? We came to this. Please have a look into it. So this is the simplest of all. This is the simplest model of all. Okay, and then we will solve one question. So this is the simplest model of all. And the PNP model also goes in the similar way, with just polarities changed. Okay. So now let us take these two examples. Yes?
What is R pi?
Sorry?
What is R pi?
Okay, so that is the base resistance, base to emitter resistance, that is internal to the BJT. R pi is not something that is connected externally. It is not an external resistor. Okay. So after this I will explain you more, so you will be able to understand. After this I will take an external resistance, and then you can see what R pi is. Okay. Okay. So now consider this circuit which is shown, where V1 represents the signal generated by a microphone. Is is equals to 3 into 10 to the power minus 16 ampere. Okay. So these kind of problems we have solved in the last class, right? So Is is the reverse saturation current, which is given 3 into 10 to the power minus 16 ampere. Beta is 100, right? So now what is IC? Is e to the power VB upon VT minus 1. So now in the first figure, this figure, you can see what VBE is, right? So first they are saying determine the small signal parameters when V1 is 0. So V1 is now made 0. Okay. So when V1 is 0, there is no perturbation, there is no small signal perturbation, and the circuit is simply behaving like a DC circuit. Okay. So what normally we do is, I just explained it to you, that normally we use a cap. Okay. So normally what we do is we have a cap here. and this cap actually makes sure that you see now if the frequency is 0, the AC signal cannot perturb here, right, but the DC will be able to bias it. Okay. So, normally we use DC coupling capacitors to make sure that the circuit is biased, and after that when we put a frequency, that signal appears along with the DC signal, so that both of them are not disturbed. Okay. The transistor is biased, at the same time the analog signal is put. So, now it is saying that the first part of the question is saying that V1 is 0, okay, and determine the small signal parameters of Q1. So, now when V1 is 0, what we can do is, we are seeing that when V1 is 0, this appears as a short, and therefore, the VBE is 0.8 volts or 800 millivolts. Now, you put that, so VT we know that is 0.026, okay, and now when you put these values, please tell me what IC you are getting. I won't be calculating, you just tell me the number. Anyone? Is this the value you are getting, or are you getting something else? So, please let me know, this has to be an interactive session. Do you get this? So, first we found IC because V1 was 0, there is no AC perturbation, there is no small signal right now, and we have simply taken the DC voltage that is there. Okay. So, now what you do after this, why we found IC? We need to find GM. So, GM was IC upon VT, 6.92 milliampere upon 26 millivolt. This will give you, okay, 1 upon 0.266 ohm inverse, okay, or 1 upon 3.75 ohms, ohm inverse, or 1 by 3.75 ohms. Okay. So, GM is equals to 1 by 3.75 ohms, and therefore, what is R pi? R pi is nothing but beta upon GM. Beta is given as 100 into 3.75, this gives you 375 ohms. This was the first part of the question, okay, where V1 is 0 and you have to find the small signal parameters. So, small signal parameters when V1 is 0 is this GM and R pi value that you got. Now, coming to the second part of the question. The second part says that now a 1 millivolt is applied. So, now V1's value is 1 millivolt. Okay. So, now when V1 value is 1 millivolt, what is the change that you are observing in collector and base currents? So, now when V1 1 millivolt is applied, you can see you can apply a KVL here, right, if in the small signal model, and you see that V1 is nothing but V pi, and you directly got it as 1 millivolt, right, and you know that R pi you just found out, R pi is 375 ohms. So, this implies the delta IB value is 1 millivolt upon 375 ohms, and this will give you 2.66 microampere. And since you know beta, then you know IC, so beta is equals to IC is equals to beta into 2.66 microampere. So beta is 100, so 266 microampere. Okay, so I hope you got this question. So the question started with a normal BJT thing, a normal BJT transistor, and they said that okay, well, let us see what are the parameters when V1 is 0. So when V1 is 0, you found GM, okay, you found R pi, beta is already given. Now if there is some V1 applied, the next is you can easily find out what is your V pi, delta IC, delta IB. Okay, and if there is some output resistance present, you can also find out what is your delta V out. Okay, so this is how the question will proceed. Okay, but now you check one thing, that in this circuit, you see whatever the change came. Okay, let's say here V1 was equals to 1 millivolt, right? So whatever this change because of 1 millivolt, that cannot appear as a voltage, right? Because 1 millivolt, the delta IC gave you 266 microampere, but this 266 microampere is getting absorbed by this VCC. There is this fixed battery here, fixed battery, because of which the change in current is not able to reflect. So what we have to do? We need to have a resistance which will manifest this change as a voltage. The resistance will manifest this change in current as a voltage change in voltage across it. Is this clear, whatever I am trying to imply? So here you see now that there is an RC 100 ohm connected. Okay, and the entire solution of this question is just the same as we did before. It's the same, everything will be same, right? Because if you found VB from this path, so RC, the presence of RC does not matter. And since you found VB from this path, you found IC from VB. So you found VB from this path. From VB you find IC. From IC you find GM. From GM you find RFI. So this is everything is going on in input side. Nothing from output matters. RC does not matter, right? But now what will happen? So we found till delta IC, right? So delta IC we found as 266 microampere. And now I am saying that, you know what, I have an RC 100 ohms, and V out I am taking from this terminal which is showing. So what is V out here? V out is 1.8 minus RC into delta IC. So RC is 0.1 K, it's 100 ohms, so I am writing as 0.1 K into IC, which is 266 microampere or 0.266 milliampere. Okay, so now you check this, what is the value of V out you are getting? 1.8 minus 0.0266, which is nothing but 1.7734 volts. Okay, and now you see that this small change has now given birth to a voltage. Earlier what was there? Earlier this RC was not there. Therefore this change did not matter because this voltage will always be 1.8 volts. Right. So therefore even if the microphone at the input is changing, because this is, we are saying that this V1 is an output signal of a microphone. Right. So even if microphone is changing, since there is no load resistor, the change does not affect us because there is a direct battery connector. So for manifesting the change, we need to connect a proper output. Okay. So let's say there is a microphone here, so there will be a speaker at output. Okay. So this is how the questions may be framed. 1 mark questions can be easily framed in this way. Okay, they won't be asking you in 2 steps, they will directly say that determine the output signal when microphone produces a 1 millivolt. That's it. So this entire process, whatever you did, part A, part B, you have to repeat. Okay, for such a question. So is this clear? Please let me know if whatever I am saying is making sense or you have some doubt. I'll come to the RPI part uh, now. So apart from that, any doubts here?
No, ma'am.
Okay, so now coming to the RPI. Okay, before that, let me explain R naught as well, and after that, we will see RPI. Okay, so I'm not going to the physics of the BJT, I'm not going to the device physics, okay, because we are not supposed to spend time on device physics here since this is an analog class. So, see, a BJT is nothing but made up of, like we saw NPN, right? So, what is these? These are just doping things, right? Semiconductors, NPN. So in between they will, as you put biasings to it, there will be some resistances present which will be inherent to the device. The device itself will show some kind of resistance to the current that is coming in. So this is R pi is the resistance that is shown between the base to emitter terminal, B terminal. Okay, this is R pi. This is owing to the nature of BJT and the way we are biasing it. This is not an external connection. So please remember that when I draw this model, this is for representing the BJT. This is the simple BJT. Okay, this is the BJT. That's it. There is nothing else. This is the same BJT, this one. Okay, so this is not actually a current source that you are actually putting there or something like that. No, this is a BJT. That's it. Okay, and this current will depend on the input you apply between base to emitter. That is what it's all about. So this is the BJT. You applied a VBE, and therefore the current which flows here will depend on the VBE, and that is what is transistorized action. A small change in input voltage causes a change in the output current of the device. Is it clear now, Neetu?
Yes, ma'am.
Okay. So now this R pi, we derived the relationship that the R pi is nothing but beta is equals to GM times R pi. Okay. Now with this we come to another term which is the resistance due to the early effect. So I am not going into what early effect is. We had seen that in our earlier classes. Okay, we had seen a small part of it. If you want to read about it in detail, you can go through the NPTEL lectures, very well explained. Okay, so there you can see what we bother about is that the IC formula changes by the presence of the early voltage. Okay, because of early effect in BJT, there is a early voltage that is present. Okay, so this early voltage basically gives rise to an output resistance, which is denoted by R naught, and R naught is given by early voltage upon IC. Okay, now since this is a resistance V upon IC, so in small signal model, where will it be? Where will it be present? So this is present between collector and emitter terminal. Okay, since this is what you saw it was VA upon IC, right? So this is R naught, like this. Okay, so now in some cases, in question itself, it will be said that the early voltage is infinity. So if early voltage is infinity, R naught is infinity. Now resistance infinite means what? Open circuit. Okay, So then in that case R naught will not be present in the small signal model. Your analysis becomes simpler. But if nothing like that is mentioned, if VA infinity is not mentioned and you have data enough to support to get an R naught, then you should calculate R naught and put it in the small signal model. Okay. So just have a look at it, and after that we will go through some questions.
Ma'am, please repeat again in which case VA is going to be.
Sometimes in question itself, the question will assume that the early voltage is infinite. There is no case. The early voltage is actually not infinite for any BJT. In ideal
Yes,
BJT, the early voltage will be infinite. Okay.
yes, ma'am.
So in that case, R naught will be taken as infinity. Okay. And in the previous question, I think one misinterpretation happened. Yeah, this is the wrong thing I have done. So basically, so when I said that V out, what will be V out? So we have found out IC, right? IC was 6.92 milliampere for this question, right? IC was 6.92. So V out DC will be 1.8 minus 0.1 into 6.92. So whatever you get from here, okay. But what is the change in the voltage? So delta V out is something which will occur because of the change in RC IC. Okay, so that will be delta IC RC. Okay, so why is it so? Because the change in, because this is nothing but VCC minus delta V out is nothing but VCC minus ICRC. So now if you say delta V out, so delta VCC is nothing but 0, right? It is a battery, so that is 0, and therefore there will be this minus ICRC. So forget the negative sign as of now. So if I say that, okay, what is the change in the V out? So you say the change in V out is delta times IC into RC, and therefore the delta IC that we found out was 0.226 milliampere into 0.1, right? So there is a 22.6 millivolt change in V out because of the change in current. So I had subtracted 1.8 also, so 1.8 should not be there because we are talking about the change. Okay. So now after the early effect thing, we will just go into some questions from our out. Okay. So now please try to solve this on your own. This question, this is a very simple question. So please solve it and tell me the answer. A transistor is biased at sorry, my microphone was off. So what I was saying is,
Ma'am, you are not audible.
yeah, I'm sorry. So my microphone was off. So what I was saying is that in the earlier question, V out, I had written that V out is equals to VCC minus ICRC, right? But what I did was I put the value of delta IC here and I calculated, which is wrong, because if I use delta IC, the equation is delta V out equals to delta VCC. Delta VCC is nothing but 0 because that's a battery, right? And minus delta IC RC. Now delta IC we found to be 0.226 into 0.1 K, right? 0.226 milliampere into 0.1 K, which is nothing but 0.0226 millivolts, 226 volts, right? Which is nothing but 22.6 millivolts. This is what delta V out will be. And what is V out? V out will be VCC minus ICRC. So VCC is 1.8 and IC was 6.92 milliamps. The change in current was 226 microampere, but the actual current is 6.92 into 0.1. So, whatever the value is will give your DC value of V out. Now, when there is a current change, this DC value will change by the amount of 22.6. Okay. Is this clear?
Ma'am, please repeat the question.
So, this was the earlier question, if you remember, right? This question was clear to you, right? When we applied an RC there, 0.1K. Hello? So this was the earlier question, and this question was clear to you?
Yes, ma'am.
So in here I did a mistake actually. I said that I had put that V out equals to this thing. V out equals to VCC minus ICRC, but by mistake I put IC's value as 226 microampere, which is not correct. IC's value was 6.92. 226 was delta IC, which we had found out. Is this okay now?
Yes, ma'am. Yes, ma'am.
Okay. Okay, so now please look into this question and tell me what answer you are getting. So what you have to find out here will be R pi small signal model, right? So you need to find GM, R pi and R naught. Since VA is given, you need to find R naught as well. So please tell me what values you are getting. Chandrasekhar, are you solving?
Yes, ma'am.
Okay. This should not take so much time. It's a simple thing, right? Take VT to be 26 millivolts. So tell me the answer quickly. You should not need any pen or pencil for this. So what will be GM? GM is nothing but 1 milliampere, since IC is directly given by 26 millivolts. 1 by 26, 1 by 26 ohms, or 1 upon 26 ohm inverse. Please mind the units. What is R pi? R pi is nothing but beta upon GM, which is nothing but 100 into 26 ohms, which is 2.6 kilo ohms. Right? Okay. And then what is R naught? R naught is VA upon IC. It is nothing but 15 upon 1 milliampere. Nothing but 15 kilo ohms. Is this fine? Okay, so I hope till there it was clear. So please note down this question now. I am waiting for a few, let me wait for 1 minute. Okay, so please note down this question and then we will start solving it. This is the second part of the question. This is the second part of the question. Okay, so now you can see the entire question together. So please take a note of the question and start solving this question, and then we will discuss it. So first you guys solve it. I am giving you 3 minutes. Just try to make the sense out of this question, and then we will start solving it. Giving you 3 minutes. Okay. So anyone who can tell what this question is about, what is to be done? Chandrasekhar, did you try?
No, ma'am.
Okay. So, and what about you, Neetu? Okay. So now see, it's a very simple thing. You have to understand the concept of input impedance and output impedance. Okay. So an amplifier with a voltage gain of 10 senses a signal generated by a microphone. Okay. So here is this diagram. See this one. The microphone is generating a signal and the amplifier senses it. After sensing, the amplifier sends it to the speaker. So if you directly connect the microphone to the speaker, it is not going to work. You need the in between, you need the amplifier that will amplify the signal. Okay. And here you see the voltage gain is given as 10. So it amplifies by a factor of 10. Now it is saying that assume the microphone can be modeled with a voltage source having a 10 millivolt peak to peak signal. Now we are saying that assume that the microphone is nothing but a 10 millivolt peak to peak signal. Okay. And a series resistance of 200 ohms is connected to it. So the microphone basically, the microphone that it is modeled, the microphone is modeled as a 10 millivolt peak to peak. That means this thing, the entire thing is 10 millivolts. 10 millivolts peak to peak in series with a 200 ohm resistance 0.2 k. So this is nothing but the microphone model. So it's just like the BJT. We saw that the BJT in small signal can be modeled like this, right? We saw this. This is the small signal model of the BJT. So just like that, the question is saying that assume that the microphone is modeled as a 10 millivolt peak to peak with a 0.2 k series resistance. Okay, this is only for this question. Okay, that microphone can be modeled like anything depending on whatever your question is. Okay, now it is also saying that let the speaker be represented by a 8 ohm resistance. So the speaker that is modeled as 8 ohm resistor. Okay, now in between you have the amplifier. Till here I hope it is clear, right? Now you have two parts of the question. The first part says determine the signal level sensed by the amplifier if the circuit has an input impedance of 2 kilo ohm or 500 ohms. So determine what signal level the amplifier is sensing. Okay, the microphone is sending 10 millivolts. What is the amplifier seeing? Okay, if the input impedance of amplifier is either 2k or 500. So now this was the amplifier. Now this is the terminal of the microphone. Okay, now the amplifier input impedance is like this, R in. Okay, and output impedance will be somewhere there. So in the output we will not see that right now. Let us see input impedance first. Now the now till here, if is it clear? So Chandrasekhar, now can you solve this question? What is the level sensed by the amplifier? Rin is given as either, what was it, 2k or 500. So Rn is, let's say, 2k. So now can you tell me what is the amplifier seeing? So what will be the amplifier seeing? Yes, we need to apply voltage division. So what is the amplifier seeing? It is seeing this voltage, this one, right? This is what the amplifier is seeing. And what will be this voltage? This is nothing but application of voltage division. This is our series. Okay, and this is what the amplifier senses. This was 0.2k and this was given in two cases. First is Rn is 2k, second is 0.5k. Chandrasekhar and Neetu, is this clear now?
Yes, ma'am.
Now can you solve it?
Yes, ma'am.
You can now find. Now see, this was a simple question, right? Voltage division. They could have given you directly this circuit, but then it is very simple. Instead, they cooked up a story. They cooked up a nice story, and you will have to come up with this diagram. Now, in the book, they have already given these diagrams, so it becomes very easy. But in GATE exam, you might not be given this diagram, and you will have to cook up the story. Okay, so now please find out the V sense value for two Rn values. First is Rn is two cases. Rn is 2k, second Rn is 0.5k. So tell me what is V sense? V microphone is 10 millivolt peak to peak. Okay, so now you can tell me V sense in peak to peak itself. Like what is it peak to peak? Like if you are taking 10 millivolt peak to peak and you are taking the value 10 and after the voltage division you get V sense as 5, then you will say it is 5 millivolt peak to peak. You understand? So now solve and tell me what you are getting. Why are you guys needing so much time? This is simple voltage division. Please tell me the answer. So what will be V sense? V sense will be Rn upon Rn plus R series into V microphone. From where did this come? So R series, R in, this was V sense, right? This is input. Let's say V input. Okay. So now what will be the current here? The current will be, if this is in this polarity, the current is V input equals to I into R series plus Rn. right? And there, what will be V sense? V sense is nothing but the voltage across Rn, right? So it will be I into Rn. Therefore, you put the value of I from here. So V input upon R series plus Rn into Rn, right? So therefore, directly voltage division rule says what? That V sense will be equals to Rn upon Rn plus R series into input. Okay. Now one of you have solved. So can others also please try to solve this and tell me what you are getting. After that we will go to the second part. Okay, but I want you guys to solve this. This is not tough. This is very easy. This is the basic of networks. So I will start with the, so I'm giving you 2 minutes. Just look into it. After that I will explain this question once again. Please look into it and I will explain the question once again. Neetu, is the question clear to you?
Yes, I'm clear.
Okay. So a few of you have joined now, so I'll just repeat the question for you. We have a microphone, okay, and from the microphone it is going to a speaker. Now if you connect the microphone directly to a speaker, it is not going to work. You know what microphone, right? It's mic, and then there is a speaker, okay. So in between there has to be an amplifier which amplifies, which receives the signal from the microphone and sends it to the speaker. So basically the speaker is your output and your microphone is your input. Okay. Now the question says that the microphone can be modeled as 10 millivolt peak to peak signal with a 0.8k resistance. This is the model of the microphone. Okay. And the model of the speaker is a normal 8 ohm resistance. This is what the speaker is. Okay. Now it is saying that in between the amplifier is there. In between the amplifier is there. Now it is saying that the microphone's output is 10 millivolt, right? Peak to peak. Now what will be the amplifier seeing? What voltage will be the amplifier sensing? If the amplifier itself has a resistance Rin, if the amplifier itself has a resistance Rin. So that is why it brings us to this circuit. Now Rin it gave in two cases. Case 1 where it is 0.5k, case 2 where it is 2k. Now if you try to find out, see what happens. Okay, so now you will see that V sense, V sense is basically, so this voltage V sense is basically the voltage that the amplifier will actually see. The amplifier which actually see this voltage which is V sense. Okay, the amplifier sees this voltage which is V sense, and now you will see that RS is fixed, right? This is from the microphone. So Rin upon Rin plus Rs, that is what we wrote, into V input. This is nothing but V input. 10 millivolt is nothing but V input, right? So now what is Rin by Rin plus Rs? This is 2 upon 2 plus 0.8. In case it is 2k, Rin is 2k. And what happens when Rin is 0.5k? 0.5 by 0.5 plus 0.8. Now just tell me what is the values you are getting. Please put it in the box. What are the values you are getting? Please tell me, Chandrasekhar, what are you getting? 2 by 2 plus 0.8?
9.09 millivolt.
Okay, so just tell me this ratio. Don't multiply it with 10. Just tell me this ratio. I am multiplying this with V input. Okay. Don't put V input's value. 5 by 7. So what is 5 by 7? I think it is near around 0.7, right? And this is 5 by 13. Am I right? So what is
Yes,
5 by
ma'am.
13? 0.3, I think. So now you see, depending on what your amplifier's input resistance is, this is Rn, right? 2 and 0.5, which is put in case. So depending on what your amplifier's input resistance is, what voltage the amplifier is seeing is depending on that, right? So even if the microphone is same, right? The mic is the same, right? And the mic is sending out the voice, okay? The 10 millivolt signal. But since the amplifier's input resistance 2k and 0.5k, so which is less? 0.5k is less. So when the amplifiers or, let me write or. So when 2k is your input impedance, you are getting 70% of the signal back. How 70%? This ratio 0.7. 0.7 times V input, right? So it's 70% of input. So when your input impedance is 2k, you are receiving 70% of the input. And when your input impedance is 0.5k, you are receiving only 30% of the input. So which one will you prefer? 2k. I will put an amplifier which has an input impedance of 2k, so that maximum part of my microphone signal is received. If I receive only 30% of microphone signal, then what I reproduce will be further less, will be further degraded. Okay, I actually wanted 100% of my signal, but when will I receive 100%? When the input impedance of amplifier will be infinite, right? Infinite means what? So input impedance of amplifier is infinite, means what? This is the microphone, This is the amplifier. So infinite means what? This is open circuit. So if this is open circuit, that means everything I have goes in, right? Open circuit voltage is what I need. I don't need the current. So VOC I have, and then I have GM VOC here, and therefore the current is completely dependent on the 100% of the signal. So now you can appreciate what input impedance is. And input impedance will depend on R pi, as we were seeing, right? It will depend on R pi, because R pi is the inherent input impedance, right? Inherent input impedance. Now you can say that, you know what, I can just put an extra resistor and increase the input impedance. So let us see whether that is possible or not. So now what I am saying is that if you have a BJT working as an amplifier, so now I am replacing the amplifier with the BJT, right? So now you have the BJT and you have this microphone stuff here, right? And let this is ground, so this is ground, okay. Now you tell me, now you say, ma'am, what let us do one thing, let us connect a impedance here. Okay, fine. So what I'll do is, this is R pi, right, which is the inherent input impedance of the BJT, that is always there. So let us say R pi is 1.1 k. Okay, now you are saying, you know what, I want to increase this 1.1 k. So how will you increase this 1.1 k? You cannot put anything here like this, you cannot do this. If you do this, this actually comes in parallel with R pi. So RB comes in parallel with R pi, and whatever is its value, it will always be less than 1.1 k. So this will not work. So there is one more method through which we increase the input impedance, and that is the presence of a emitter resistance. Remember, this RB resistance here is for the DC biasing. It has got nothing with the input impedance, because the signal will always come like this, right? It will see what is in parallel to it. Okay, the series resistance only matters with the drop of the current, which is nothing but used for the DC biasing of it. Okay, what you see in parallel is what will matter. This will only be added. This is not what you should be worried about. So now let us see how presence of RE affects the circuit. Okay, so now let's come to the small signal model. So we had R pi going between base to emitter, right? And then I had this source, which is GM times V pi, and we saw that V pi is nothing but the voltage across R pi. So when I write plus minus like this, that means it is between B and E, okay? And then the emitter resistance is there from emitter to ground. So this is your ground here. This point here, E is not ground. This is emitter point. And now when you apply the signal, you apply it like this, plus minus V in. Are you getting this? The signal is with respect to ground, and RE is connected between E and ground. So E is now no longer ground, and now your R naught is here, and this is the V out. Okay, so now let us say that this was my so this is what I am talking about. Okay, so this is plus minus VB is for the DC biasing that we already saw. So when you draw the small signal model, all your DC sources will be zero. All your DC sources will be zero, and let us say you have an RC here, and this is again connected to VCC. So small signal model, DC source is 0, so VCC is 0, and RC is now connected between collector and 0. So here is your RC. Is this model clear? Please have a look. Please have a look. Small signal, DC sources 0. Okay, after this we will go into the derivation, but first just have a look into it. Please let me know when to move forward. Okay, I am just leaving it for 1 minute here. Now the emitter resistance is also used for, the main purpose is actually to increase the input impedance and bias stabilization. Okay, this is used to increase your stability of the circuit, but everything has a downside as well. So this degrades your voltage gain. So we will see how it degrades the voltage gain. So if you perform so I will not be doing the entire proofs here. So if you do the proofs of this circuit, if you try to find the voltage gain, current gain, everything, you will see that the voltage gain reduces as compared to the circuit where emitter resistance is not present. Okay, and also you see that earlier whatever VBE you had put here, okay, suppose 0.8 volts you had put. So earlier when there was no emitter resistance, directly if you put a VBE, that was sufficient to bias your base to emitter, right? But now what will happen? It will encounter the drop of BJT VBE plus the drop across RE. So now 0.8 volt is not enough. That means the voltage that you are applying is actually increasing. You get my point? So your power dissipation will increase because of the presence of RE, but RE is needed for bias stabilization. That is a different topic. I'm not going into that right now. As well as it increases the input impedance. So now how it increases the input impedance? So for sake of simplicity, I am considering R naught to be infinity. Okay, so there is no R naught present right now for the sake of simplicity. Okay, so now you see that your current IB goes from here, right, and this is IC, and what goes in RE is IB plus IC, right. So now you apply the loop here. So what will be your RN? Rin will be Vn by IB, right. So now please put a loop here. Please put a loop here, write the equation. I will write it after 2 minutes. Vn equals to, what is the equation you are getting? So I want it to be an interactive session because I already know the derivation. So I want you guys to do this derivation, okay. So please derive it and let me know that, okay, we have written the KVL equation, you let me know that, okay.
Ma'am, V in is equal to IB R pi plus RE IB plus IC.
IC. Okay, good. Now what is IC? What is the value of IC? IC is nothing but
GMR pi.
GMV pi. GMV pi. So now put that value there.
Yes, yes.
Okay, put the value there. And then what is V pi? V pi is IB into R pi, right? So again put that value as well. And then tell me what Rn you are getting.
Ma'am, you have written capital B. R in is equal to V in upon
But
IB.
that doesn't matter, it's just a notation. Okay, so you can write it as small b, that doesn't matter. So V in first equation is V pi plus IB plus IC into RE. IB we know is nothing but V pi by R pi, because it's the drop, right? It's the drop across R pi. And then V in is equals to, and we know IC is nothing but GM times V pi, right? And therefore V in equals to V pi plus V pi by R pi plus GM times V pi into RE, right? So now V in upon, what is V pi? V pi is IB R pi equals to R pi plus 1 plus GM R pi into RE upon R pi. Now R pi gets cancelled out, you get V in by IB equals to R pi plus 1 by plus GM R pi into RE. And then in place of GM R pi you can put beta, that is nothing but the amplification factor, right? Now you see your input impedance has increased. Okay, can you find out V out upon V in? Please find out V out upon V in. Please find out V out upon V in. So take a note of this and then try to find out V out upon V in. And after this we will do a solution for R out, how to get R out from the circuit. Okay, so first find out V out upon V in. Let me know when it is done. Okay, it is simple, it's just now you have to put a KVL from the output loop and you have to now combine V out and V in and eliminate any other variable. Variable means IB, IC, IE, all these things, they should be eliminated. V pi only, it should be only in the terms of resistances that are there in the circuit, resistances or admittances. So find it in terms of V out upon V in. Giving you 5 minutes. Okay.
Excuse me, ma'am.
Yes.
Ma'am, I got the answer.
Okay.
RC R pi upon Rn.
RC R pi upon Rn.
Yes, ma'am.
Okay, so let others verify it for you. Others, please let me know if this is correct. Avinash, can you just cross check it once? You are missing one term here. Okay, just cross check it once. You know how I told you you are missing one term here? I did not do any derivations. How can anyone tell me if how I knew this is wrong?
Minus sign.
No, 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 not minus sign. Check the units. What will be the unit of whatever your exactly unit? So Hari Prasad has said the unit. So R is ohms, R pi is also ohms, and Rn is also ohms. So your answer is in ohms, where you are finding voltage gain. This should be unitless, right? So there is one term which is missing. I know which term is missing, but I will not tell you. So if it is in ohms, that means what you are missing is an admittance. You are missing GM there. So just cross check your derivation. You will find the answer will be GM R pi into RC by Rn. Might be. Just check it. Okay.
Yes, ma'am. Yes.
Okay. So that's how you check. In gate, you won't know that whether you have done a silly mistake or something. You just check your the units you have done. Okay. That is one way of cross checking things. Check the units. So this is a good point that came out. Good. We can make mistakes here. There is no shame in there, but because the mistakes should not happen in gate exam. So please,
Yes, ma'am.
okay. So others, please derive it quickly. I'm give 1 more minute is there, and then I'll do the derivation.
Ma'am, you are not audible.
Yeah, I wasn't speaking as well. Okay. So just look into it. I think it is self-explanatory. I did not speak anything, right? Now till here it is self-explanatory, right? So now we do another approximation here, which is V out upon V in. I can write minus beta into RC upon. So beta is very high, right? Beta is very high. So, and beta came from where? It came from GM R pi. So it came when I multiplied GM with R pi. So therefore obviously beta is greater than R pi, right? Beta is greater than R pi. Okay. So in normal cases, you can say that okay, beta is greater than R pi. So I am assuming that beta is very greater than R pi. Beta is very greater than R pi. Okay. So now in this case, what will happen? Beta into RC, and I can approximate the below term. It is R pi plus 1 plus beta RE. So it is like saying R pi plus beta into RE, right? And which is nothing but saying it is same as beta RE because R pi is very small. Okay. So therefore I can approximate the denominator as beta into RE. And therefore you will see, Chandrasekhar, you had sent me this question, right? That I'll take that question after this. In there you can actually use this formula directly, minus RC upon RE. So for a BJT with NPN transistor where it is biased in active region, you are taking the output from your collector, which is common emitter configuration. So C configuration, if emitter resistance is present, you can actually do this. And in gate it is seen that many times these kind of questions are asked for 1 mark. They will give you the circuit like this, and they will say beta is very high, like this something they will say, this is 10k, this is 1k, and they will say beta is very high, find the voltage gain. Answer minus 10, that's it. Once they have written beta is very high, you need not do any calculation. If they have mentioned beta's value, if they have mentioned something else, IC value, beta value, other parameters are there, then you need to calculate and find. Then you might reach the value as 8.9, 9.1. Then in this case, you will have to solve and see. But in the question, if there is nothing else given, only the circuit, beta very high, like this, you don't need to see anything, just divide them, make sure you are putting the correct sign. If they have not asked the mod value, your answer is there. Am I clear? This, and you will see these questions are there in gate. Okay, same with what? MOSFET, common source configuration. Okay, source, there is this resistance, drain resistance, there is this resistance, source resistance, your output your voltage gain is minus RD upon RS. Okay, if the amplification factor is very high, just make sure what is the language of your question. Okay, don't bypass the language of the question. You don't think that okay, I just saw this and I'll write minus 10. No, see if there is things written there, if you have to find IC and all the stuff, you will get the output like this, 7.89, 8.9, like this, and in that case they will not consider 10, and most of the cases this will be a numerical answer type. Okay, but the maximum value will be minus 10, it won't go over that. I hope I am clear. And okay, when there is no emitter resistance present, you will get the voltage gain to be RC upon RE, small re, and small re is nothing but 1 upon GM, it is nothing but GMRC, like this, minus GMRC. This is what is when there is no emitter resistance present. So please derive and see that. I am not doing that derivation. Okay, I hope this one is clear. After this I'll take the output impedance. So just go over this once and then we will move forward. Okay. I'm giving you 1 minute. Just go over this small signal model. For those who have already understood this, then just remove RE and then try to find out what is the voltage gain. Okay, I'm giving you 1 minute for this. Try to find out the voltage gain without RE present in the circuit. One minute more. After this, we will do the derivation of R out. Okay. Okay. So I hope you are getting it. If you are not getting it, then you solve it. Okay. So yeah. So now let's say that I have this transistor. Okay. What is the R out here? Okay, and VA is not equal to infinity. That is R naught is present in the circuit. Hmm? So let us draw the small signal model. Now just look into it. This is the emitter terminal, right? This is the emitter terminal which is grounded, right? That is R pi is between base and ground. Okay. Therefore, you can see that V in equals to V pi. Correct? Okay. Now you see one more point. Oh, sorry. This also has to be connected. Yeah. Okay. Now you were asked R out. R out will come where? You see I have marked it here in the transistor. R out is from collector. So I will say R out is here. Now what is the rule of finding any output resistance? Output resistance are often termed as Thevenin resistances. which is found by making all independent current and voltage sources 0. Okay, so when you make a voltage source 0, that is short. When you make a current source 0, that is open, but they have to be independent. Now you have a dependent current source in this circuit. The GMV current source is a dependent current source, so you cannot make it 0. What you can make 0 is V in, because that is independent. What is meant by independent? Independent means it is not depending on anything. It is a battery by itself, let's say, or a source by itself. Whereas GMV is dependent because it is dependent on V pi. Now what I'll do is, for finding the Thevenin resistance, I have to connect plus minus. I will connect here VTH and ITH. So VTH, and from VTH which supplies ITH current into the circuit. Now VTH by ITH will give me R out. Okay, actually it is not called ITH, it is called ISC, which is short circuit current, but anyway. Okay, so now I connect this with the condition that I make independent sources 0. This is network analysis. Okay, I am repeating it, independent sources 0. So this is 0. Once V in is 0, V in was equals to V pi, and therefore that also is equals to 0. Now since V pi is 0, therefore GMV pi is 0. It is not 0 because it is coming under independent source or something. This is a dependent source, mind you. So let me write it. GMV pi is dependent source whose value is becoming 0 because V pi is 0 due to independent source V in 0 because of the condition for finding output impedance. Is this line clear, or do you need any explanation? Just ponder over it.
Yes, ma'am.
It is clear, right? Okay. So now when that becomes 0, now your circuit is not left with anything, right? If this is 0, that means there is 0 current here. That means ITH, the entire ITH flows from R0. Therefore, VTH by ITH is nothing but RC. That is equals to your R out. Okay. So this is your R out. Now when you have an RC in this circuit, so let's say you had this circuit. So RC will then, now R0 is also there. So RC parallel R0 will be your R out. Okay, RC will come in parallel to it. Understand? Now let us come to a slightly different part where I say that R out is from this terminal. What if I see the resistance from this terminal? What it will be now? Can you derive it? What will be the resistance R out now? It's a bit tricky, but you use the same method to do it. Okay. Take RO as infinity. Take RO as infinity. It will be simpler. So take RO as infinity. There is one more condition that I did not, like, I kind of assumed it. So you see that independent sources I said. So now you will see that this is reduced to this. this is ground and this is ground, so both are AC ground. Okay, and now in this case your base is AC ground, and now you solve it. Take VA as infinity.
R pi upon 1 plus beta.
Let us say, let us see, Vx upon Ix is R pi upon 1 plus beta, which is nothing but 1 upon 1 by R pi plus Gm by R pi. That is what you are saying, right? Yeah, Gm by R pi, and then you have Gm R pi by R pi. We have 1 by 1 by R pi plus Gm. Yes, that is correct. This is what you will get. You will get R by 1 plus beta. Okay, so this is a very important result. Actually, you will be facing this, might come from gate point of view. So you see, this is nothing but Vx upon Ix equals to 1 upon 1 by Gm plus R pi, right? So what is sorry, just wrote the opposite thing. So what is happening? See, Vx by Ix is resistance. We are finding out R out. Again, look into the units. 1 upon admittance should be R out, right? Resistance. Now admittance is what? Admittance is what? Gm is admittance. So Gm, I am writing the admittance, right? And 1 upon R pi will also be admittance. So plus 1 by R pi. So, and when, so this entire thing is admittance, 1 upon that will be resistance. So normally what you will find in books is this term. You won't find R pi by 1 plus beta everywhere. This is also correct. I mean, this is the same thing, but you will see mostly you have this term. 1 upon Gm plus 1 by R pi. And usually it is seen that R pi is very larger than 1 upon Gm, and therefore whenever in this kind of a condition where you are seeing the resistance from this side, from the emitter side, and you have your base AC ground, and you are seeing it from resistance side with Va infinity, you will see that they directly take it as 1 by Gm. And the question will come in a way that the complication will be somewhere else. They might increase the circuit, they might add different elements, but you will see that R naught they would have taken it as infinity or something. Even if they don't take R naught as infinity, you will see most of the time it will come in parallel with 1 by Gm. Okay, you can put the concept and solve it and see. Okay, so let others finish it. I'm giving 2 more minutes, and after that there were 2 questions sent to me. I will take them. Okay. So Chandrasekhar, Neetu, did you guys do this? Were you able to do this derivation? You had to find Vx by Ix from here. So I'll give you 1 more minute. Just note everything down, and then please go over it. Okay, go over it once again. Rotate my screen, maybe then it will be better visible. Okay. So Chandrasekhar had sent me 2 questions. Okay. So Chandrasekhar, I will show that question here. I forgot whether I had taken the screenshot. Yeah, I have taken the screenshot. Okay. So let me do the MOSFET question first. Okay. Now you guys can tell me what is the answer. So you guys first solve it. I'm giving you 5 minutes. Please solve it. Tell me what the answer is, and then I will solve it. Okay. It was a easy question actually, but anyways. You remember they are asking for small signal voltages. They are not asking DC. They are asking for small signal voltages. Okay. So read the question and tell what the answer is with the trick that I just told you. Did anyone get the answer? Two minutes more, okay? Try to solve it, it's easy. Any idea how this will be solved? Consider the circuit shown with an ideal long channel N MOSFET. The transistor is appropriately biased. They have already given that the transistor is biased. Okay, they have not given any DC voltages because it is not required. They have said that it is acting as a linear amplifier. Okay, it will amplify. So Vi is the input and Va and Vb are the small signal output. So I don't need any DC here. Okay, now you see this is nothing but AC. Since these are small signal voltages, all the DC sources will be 0. VA is this one, right? So VA is what? If it is not a MOSFET, if it is a BJT, then it is a common emitter amplifier and VA is the collector voltage, and therefore I just showed you that VA will be RC by RE for BJT and RD by RS for MOSFET with a minus sign. That is what VA is. So VA is nothing but what? Minus 4 by 2, minus 2, that's it. Done. Now coming to VB. What is VB? See, the circuit is not two different circuits with two different outputs. It is one circuit and I am taking, if I take one terminal A, that output, if I take one terminal B, that output, how will it behave? So now that circuit has now become a common drain, or if it is a BJT, it is common collector for a BJT. Right? So now for common drain and common collector, what is the output? Gain is, voltage gain is 1. Right? So VB is nothing but plus 1. That is a maximum value. It is always less than 1. But since in the question there is nothing else given, I'm taking that to be 1. So now my ratio will be nothing but VA by VB is nothing but -2. Answer. That's it. Nothing else to be done. Wasn't it simple? So all you need to do is you need to know the configuration. So if in BJT, this is the input applied and this is RC, RE. If the output is from, this is AC, right? AC ground. So if the output is from here, this is common emitter. Same circuit. Output is from here, common collector. This you should know, okay? Common collector, common emitter. For common collector, the voltage gain is always less than equal to +1. For common emitter, I told you with approximation it is minus RC upon RE. It is not, so in the question now you can say that, oh, we thought it is one is VA, one is VB. No, it is a circuit. Circuit is already made. Now you are just putting your oscilloscope or your, yeah, you have to put the oscilloscope because there is a AC signal. So you are putting the oscilloscope in VA with respect to ground, you are seeing out voltage output. And when you put the oscilloscope terminal in VB with respect to ground, you saw something else. So basically, if your input from function generator is like this, 1 -1, then your oscilloscope at VA oscilloscope will show 2 -2 and VB will show us 1 -1. Phase change. Phase will be changed. Sorry. Because for common emitter or common source, the phase changes. Do you understand now? This was asked in 2022. Just have a look into it. Then I'll go to the next question. Please let me know if it is done. Okay. So the next question that Chandrasekhar sent was this one. So Chandrasekhar, this is not an op-amp question. This is actually a DAC question. This is a digital electronics question. Okay. So digital to analog converter. This is a digital to analog converter. DAC, you will study about it in digital electronics. This is an R to 2R ladder DAC. So I'm not going to explain it. Okay, I'll just tell you with the help of formulas. You go into this concept and you read it yourself. Okay. This is called R to 2R ladder. So my laptop's battery will go now.